Hello everyone. Thank you for joining my presentation. I'm Ehab Elhosary,
and utilization of 3D data and
under the
point
supervision of
data
Professor Osama
at
Moselhi.
small and medium
I will be presenting our paper, Utilization of Artificial Intelligence in HAZOP Studies and Reports. I will start with introduction and literature review to introduce the principles and the importance of this method, the current models that have been developed to facilitate the conducting HAZOP studies and current implementation. Then moving on to proposed method to address one of the main limitations, then implementation, and finally concluding remarks. So let's start off with the basics. What is HAZOP? I know it's a little bit very different from the construction industry. So it stands for Hazards and Operability Issue. It's the most widely hazard identification technique in the process industry to identify any potential hazards that can affect personnel or equipment or environment, as well as operability issues that can affect operations efficiency to eventually enhance safety practices. This method was originally developed after a massive explosion of a methanol chemical plant in the UK in 1974 and resulted in a loss of 28 lives as well as many injuries on site and off site, and also many properties destroyed around the site. So it was very important to develop this method instead of waiting for other explosions to occur. This method also has been extended to other industries like oil and gas and petrochemical plants that have similar potential to this kind of explosions and accidents. It has gained of a lot of acceptance and became like a guide or a standard in the process industries. So the first standard was released in 2001 and updated in 2016 to detail how this method is conducted. So to conduct this method, it mainly consists of three main phases. The first one is definition and preparation to define scope, node boundaries, collect technical data like mainly a piping and instrumentation diagram, which are the design drawings. As you can see here, this is an example of a P&ID or a piping instrumentation diagram of a crude oil plant. The next phase is organization to divide the whole system, the whole design into a small manageable section, which referred to as P&ID nodes. So for each particular node, for example, this is the first P&ID node, which is water injection system. We're moving forward to the last phase, which is execution by applying a set of guide words and parameters together to reveal any kind of hazard and operability issues, and also identify their root causes and consequences on the whole system. Then identify safeguards and recommendations that can prevent or mitigate this kind of hazards. Then all these elements are summarized in a final HAZOP report. As you can see, these reports including different elements like guide words, hazard, causes, consequences, safeguards, and recommendation. And each row in this report referred to as HAZOP note or HAZOP record. So to clarify, we have main terminologies here in this study. We have P&IDs, which are the design drawings. We have a P&ID node, which is a small section from the design. We have a HAZOP node or a record, which represent each row in the report. And later on, after analysis, we have topics, which represent the main clusters of causes, main clusters of consequences, and main clusters of safeguards and recommendations. So as we have seen, this method is very organized and structured. However, it has some limitations, like prone to human error, time-consuming and expensive. Inadequate definition of scope may cause some difficulties to identify hazards, missed hazard due to focused discussions, and knowledge loss. So to address this limitation, different kinds of models have been developed, like data mining techniques, including classification models, like, for example, predicting deviations based on causes using bag of words and machine learning classifiers. We have also topic modeling techniques like LDA, the most common method in topic modeling techniques, used to cluster or categorize the main elements like cause and consequences into main topics or main categories. So, however, these models have some common limitation, like, for example, they partially automate some specific aspects of HAZOP elements in the reports and ignore others. Also, they are missing node-based clustering and hazard prioritization. So to clarify here, topic modeling techniques like LDA cluster the HAZOP elements like cause and consequence into topics or main topics at the plant level. But if we look at the procedures of HAZOP studies, we can say that HAZOP participants analyze each P and ID node individually. So we need to categorize these elements at the node level. Another key limitation also is lacking integration with P and ID nodes, which is very important to ensure correct applicability. So in this paper, we focus on the second limitation. So to address this limitation, we developed a model using topic modeling technique, which is the most advanced topic modeling technique. Starting with data preparation or data pre-processing, then embedding instruction to convert HAZOP elements into high-dimensional vectors, then reduce dimensionality using UMAP algorithm, then identify the main topics or main clusters using HDP scan, then identify the most meaningful keywords that represent each topic. And the resulting topics are then evaluated by using coherence score and topic diversity score paired with human judgment to ensure that the final topics are actionable and acceptable. So this model was applied on an oil pump station case study, including 6 main nodes and more than 1,500 HAZOP records or nodes. As we have seen, this sample from the dataset that we use in this paper. And by investigating this dataset, we have observed that HAZOP elements often recur across different kinds of P and ID nodes, and even within the same node for different deviations, like, for example, here, fire and equipment failures. So this kind of repetition indicates the potential of automation and reuse past insights in similar P and ID nodes and structures. So we applied BERTopic model on this case study and experimented with different hyperparameters to get high performance in terms of coherence score and diversity score. And we started with the number of topics with high performance and investigated these topics to ensure that there are overlap or similar topics that should be merged afterward. Then until achieving or until getting the final topics that achieved coherence score of 80% and topic diversity score of 92%. So in this case, we identified the main risk factors because we applied on causes from a HAZOP report. So the main risk factors for for each P and ID nodes have been identified. For example, here in the slope system, the node number 6, the most risk factors are pump failure and malfunctions and valve error and failures. Yes. So also now we have identified the main risk factors for each P and ID node, but we need to focus more on high risk hazards. So to do so, we have to look for the topics or risk factors or causes with high likelihood of occurrence. For example, here, the second node, we have topic 9, which is chemical leaks or leakage, which has the high likelihood of occurrence. Also, we have to also look at the topics or risk factors with low likelihood of occurrence, but frequently repeated across within the same node. So we have to investigate these topics to avoid escalating the overall risk. Also, the identified risk factors were validated by comparing with manual analysis conducted by the authors of this case study. And the manual analysis factors indicates strong alignment with the generated topics by our proposed model. So this indicates the effectiveness of the BERTopic model, and also it's quite promising to use the AI algorithm to automate HAZOP elements and reports. So to conclude, we went through introduction and literature review to introduce current models, the importance of this method, and current limitation. We proposed a BERTopic model to address one of those main limitations, and then applying BERTopic model on a case study to identify the most dominant risk factors for each P and ID node. And the contribution of this study is to reuse past insights and similar P and ID nodes and structures to reduce the time and effort for conducting HAZOP studies, and also reduce the hazards and accidents reoccurrence to create safer operating environment. However, it has some limitation just to consider in future works, like expanding the data set and also optimize the hyperparameters of BERTopic model. So thank you so much for your attention, and